Question 12d. At time t, the displacement x of a particle satisfies t equals 4 minus e to the power of negative 2x. Find the acceleration of the particle as a function of x. It is given that t equals 4 minus e to the power of negative 2x. I'm going to call this equation number 1. Differentiating t with respect to x, we get dt dx is equal to 2 times e to the power of negative 2x. Taking the reciprocal of both sides, we get dx dt, which represents the velocity of the particle with respect to time, is equal to half times e to the power of positive 2x. So we have the velocity of the particle with respect to time, but expressed as a function of the displacement x. Now, rearranging equation number 1 to make e to the power of 2x the subject, we have e to the power of negative 2x is equal to 4 minus t. Taking the reciprocal of both sides, we get e to the power of positive 2x is equal to 4 minus t to the power of negative 1. I'm going to call this equation number 2. Hence, dx dt is equal to half times 4 minus t to the power of negative 1, which is the velocity of the particle with respect to time, but expressed as a function of time. Now, the acceleration is the derivative of the velocity. And using the chain rule, we have a is equal to negative half times 4 minus t to the power of negative 2 times negative 1, which equals half times 4 minus t to the power of negative 2, which equals half times 4 minus t to the power of negative 1 all squared. And replacing the 4 minus t to the power of negative 1 with e to the power of 2x from equation number 2, that equals half times e to the power of 2x all squared. Therefore, the acceleration as a function of x is a equals half times e to the power of 4x.